Continuing the multiplication assessment study guide with question number 7. There are 120 people attending an assembly. They will be standing in rows. Show 2 possible arrangements of the 120 people. Each arrangement should include a sketch showing the rows and the number of people in each row. If you remember in class, we said all you have to do for something like this is literally show the rows and write, for example, row 1, row 2, row 3, and however many rows you're going to have, and how many people go in each row. And what should that equal? It should equal 120. So if you haven't done this problem yet, please go ahead and do it on your own, and then turn the video back on. So there's so many different possibilities of this. Let's just say that I wanted 10 rows. 4, 5, 6, 7, 8, 9, 10. So I'm going to abbreviate now. Row 4, row 5, row 6, row 7, row 8, row 9, row 10. So if I had 10 rows with 120 people in each row, how many chairs would I need in each row? 120 divided into 10 rows. Well, you should know that. 120 divided by 10, you should know that that is 12. So there are 12 chairs in every row. So I'll write 12, 12, 12, 12. It's a little bit of a pain to write that every time, but it helps me make sure that you know what you're doing. Okay, so we have 10 rows with 12 chairs. Now it said we should do a second arrangement. There are actually many ways you could do this. Let's do another arrangement, and let's see, we could have 60 rows with 2 people each. That doesn't really make much sense. We could have 30 rows with 4 people each. Oh, what about 4 rows with 30 people each? 1, 2, 3, 4 rows with 30 people each. How did I know that would work? Well, I know that 30 times 4 equals 120. That's what I want. I want room for 120 people. So there's my second arrangement. So here's my first sketch and my second sketch. And the question said each arrangement should include a sketch showing the rows and the number of people. I've done it. Okay, let's look at number 8. It says that the people standing in an assembly need 19 inches of space from side to side. And each row takes up 24 inches front to back. Choose one of the arrangements and show the dimensions of the space that you would need. Okay, so these are people standing. Well, let's use the 30 example. How would we do this? Each person, so let's say we have a lot of little people here. According to this, each person needs 19 inches. So for every person, you need 19 inches, side to side. So how many people do we have? We have 30. So to figure out how much room 30 people need, we would need 30 people times 19 inches each. That will tell us how much space we need this way. How about this way, front to back? Well, it says each row takes up 24 inches front to back. If each row takes up 24, we have 4 rows. Wouldn't that just be 24 4 times? So we have 2 multiplication problems. So whichever way you decided to do this problem, I'm going to ask you to stop the camera now and see if you can finish it out yourself. And I'll finish mine with the box multiplication coming up here. So I was supposed to do 30 times 19. You know, I think I'm going to write the 30 on the side this time and the 19 on the top. I guess it really doesn't matter which way you do it. 30 times 10 is 3 with 2 zeros. 30 times 9 is 3 times 9 is 27 with a 0. Let's do a really quick ones, tens, hundreds. We have 0 ones. We have 7 tens. And 5 100s. So remember, our chair arrangement is going to be 570 inches wide. That's enough space for 30 chairs that are 19 inches each. So what about our rows? We had 4 rows times 24 inches. The problem told us to use 24. So let's do 4 times 24. 4 times 2 is 8, add a 0, and 16. So we have ones and tens, 6 ones, 9 tens. So that's 96 inches. So what we're saying here is it would take 96 inches to have 4 rows that take up 24 inches each. Okay, so our dimensions, and I'll box this answer, are 96 inches by 570 inches. Let's look at the next one. Number 9. Josie is making treat bags for her parties. Each treat bag will have 5 candies in it. How many candies does she need? Okay, so 70 treat bags with 5 candies each. We could draw 70 bags with 5 things in them each. It would take a really long time. Multiplication is really good when you have to repeat something over and over again. We have 70 bags with 5 candies in it. We have to do 5 candies 70 times. So that could be 70 times 5. So we can make a chart for that. Actually, we just do it just like this. It's a 1-box chart, isn't it? 7 times 5, 35, and a 0. She would need 350 candies. Let's look at number 10. A table has an area of 12,000 centimeters squared. So they told us the area. Remember, area equals length times width. So if they already told us that the area is 12,000 centimeters squared, and they told us the width is 60 centimeters wide, all we need to find is the length. So we can do this like algebra. 12,000 equals 60L. What do you do now? Stop the camera and try to solve it on your own. And divide both sides by 60. Do you remember this trick? When you have a lot of zeros in fractions, you can just cancel. So now we have 1,200 divided by 6. Well, 6 times what is 1,200? Maybe 6 times 2, right? And then how many zeros do we need? 2 zeros. 200 equals L. Okay, and let's make sure. Is 60 times 200 12,000? It is. 6 times 2 is 12. 3 zeros. So it would have worked even if we hadn't canceled out the zeros. Oh, and the length is, sorry, the length is in meters? Centimeters. 200 centimeters.